Hi there, and welcome to part 2B of the BR Standard Class 4 460 tender locomotive build. We're going to continue further workings on these buffer heads. We're going to put the 1.5 degree rake on the back of the buffer head, and we're going to machine the pockets for the springs, and also we're going to drill and tap for the retaining bolt. In the extreme end of the buffer near to the springs, we can see some number identification marks indicating which of the buffer pairs came from the same parent stock. We concluded part 2, where we just turned the main shaft diameter to size, and still required to put the 1.5 degree rake on the back of the buffer head. Although this image isn't relevant to the task that we're actually performing with the buffers at the moment, I've just included it because it shows the top slide in the position that it normally is in when you're working with the top slide. But to form the 1.5 degree rake on the back of the buffer head, I had to swing the top slide over to the left 90 degrees to where it currently is now, such that the handles that operate the top slide were almost directly over the handles that operate the cross slide. Looking closely at the base of the top slide, we can see that I've drawn on a pencil mark, and that pencil mark needs setting up to the 1.5 degree marking on the circumference of the degree scale that we can see below it. I had to put the pencil mark on because at the other side of the top slide swivel, the scale actually runs out, so it would be sheer guesswork where the mark on the top slide bottom was. Let's have a look at a video so we can actually see what's going on with these markings. So here's the top slide of the lathe, and on the top slide there is a mark on this casting on the base, and the mark reads off against this scale which is in degrees around the circumference of the base. And basically, if we can see there, we've got a 0, so when the mark, which is here, when this mark is over 0, we should be cutting parallel to the lathe bedways. But with this protractor type reading on here, which is in degrees, it goes round that way to 90 degrees, and it comes round this way from 0 to 90 degrees again over here. But to get my 1.5 degree, the only marking on the base is this line here. So having loosened off this screw here, such that this can swivel, I then move that from 0 to 90 round here. But when I've got to 90, as we can see, the scale actually runs out, the degree scale runs out at 90. So I wouldn't know where 1.5 beyond that was. And currently I would be cutting directly across the lathe at 90 degrees, but I want to be 1.5 degree beyond that. So what I did, I came round to this side of the casting where the manufacturer hasn't left us a mark, but again we can see the other scale ending at 90 round the other side here, and we can see that I put on a pencil mark of my own on the 90 degree mark there. And so all I had to do then was move that degree mark onto 1.5, and that would then mean that I was cutting at 1.5 degrees beyond the full 90. But obviously it's a guess at this side, but because we've marked it with a pencil at 1.5 degree on the other side, we know that we are 1.5 degree, and we can cut the 1.5 degree taper on the back of the buffer. It may be that your lathe has a marking on both sides, but mine hasn't, so I just put a pencil mark on mine. And then of course the top slide would want locking off in that position such that it didn't move. Once we've got the top slide swiveled round to the 1.5 degree, we can actually start to face across the back of the buffer head by simply winding in the top slide until the radius tool just nicely came into contact with the finished diameter of the buffer shaft. But to incrementally move the main carriage along and then obtain a 1.5 degree cut along the back of the buffer head, I had to lock the carriage off with the spanner, as seen here. The top slide would normally be used in a fashion such that it travelled parallel to the lathe bedways, thereby being able to produce long cylindrical surfaces. But because we've arranged it now such that we can cut almost at 90 degrees to the lathe bedways, we've now lost the facility to move along the length of the work. So to move the tool along the length of the work, such that we can take another facing cut and another facing cut and another facing cut, until such times as we've got a nice 1.5 degree rake on the back of the buffer head, and also a nice radius where the rear of the buffer head meets with the shaft of the buffer head. I had to use the main carriage to move along the length of the workpiece. Without the carriage being locked off so that it couldn't move, after each incremental movement of a few thousandths of an inch, I wouldn't have obtained a true 1.5 degree rake at the back of the buffer head. The length of the buffer shaft was irrespective at this point because we knew that it was over length and needed to be faced back to the correct length later. With the angle and the radius now set on the back of the buffer head, the buffer shaft could be measured ready for facing off. Once the main shaft of the buffer had been faced to length, it was then time to turn my attention to bringing the diameter of the buffer head to size. The diameter of the buffer was turned to size but left with an over thickness head, such that a machined radius could be put on the front face of the head later. When all the dimensions of the buffer head were correct, then attention could be turned to forming the pocket in the back of the buffer for the spring. The revolving live centre was removed from the tailstock and replaced with the Jacob's chuck. The chuck's jaws were retracted into the chuck, and then the chuck was seated in the Morse taper with a soft mallet. A centre drill was put into the chuck and tightened up with a chuck key. Then we were ready to create a larger centre than the one we'd been using to support the work previously. A large centre was formed ready to drill the hole deeper. The centre was replaced with a long drill. Then a ruler was put across the face of the work and the tailstock brought back in until the point of the drill just nicely touched the ruler. This would give us then a location where the drill was almost touching the back of the buffer, at which point, looking at the tailstock measuring quill and noting that figure, we would then know on this quill reading how far to push the drill in to make our pocket the desired depth. The tailstock was locked off, such that the hand wheel on the back of the tailstock could be used to push the drill forward into the workpiece. Lubrication was applied to the drill. The hole was drilled to the required depth, but the drill kept being withdrawn to remove the swarf, and a brush was used to clean the end of the drill each time before it was re-entered into the workpiece. The same process was repeated several times, incrementally increasing the size of the drill until such times as we reached the size of the pocket required to house the external spring diameter for a working fit. As the diameter of the drill got larger, the lathe speed was reduced. A standard drill will always leave a cone at the end of the workpiece, so I then inserted an end mill the same diameter as the drill so that it could remove the material that wasn't removed by the point of the drill due to the flutes on the drill. Again, the end mill was brought up to the ruler that had been put back in place to establish where the end of the workpiece was, such that the tailstock ruler could be used again to gauge the depth of the hole and how far this cutter needed to go in to form the bottom of the hole. Once the machining operation had been completed, we then had a flat bottom to the hole and our chosen spring could be inserted. We then needed to set up and cross drill the hole and tap the hole. That would have the retaining bolt screwed into it, such that the buffer head would be locked within the buffer stock when the stock was made. The bolt in the buffer head has absolutely no bearing on the spring whatsoever. To drill the cross hole, I have an attachment which fits in the tool holder for the quick change tool post. The attachment is locked into the tool holder with the 4 machine screws that we can see. The attachment is simply a piece of round steel which has been drilled through to accept the shaft which holds the drill chuck on one end. There is a ball bearing race at each end of the tube that was drilled. The bearings are a press fit into the steel that we can see held in the tool holder, and the thin rod with the chuck attached is a sliding but close fit through the bearings, such that the chuck position can be moved, and with a portable drill attached onto the far end of the piece of steel rod, then the chuck can be made to turn and used as a drill. I must give credit to this drilling accessory to a gentleman called Steve Jordan, who showed the making of a tool like this on YouTube. He has a great channel with great content on there, so thanks for that, Steve. Check him out. When the attachment is set up in the tool post, a dial test indicator is applied and the top slide wound backwards and forwards to ensure that the sliding shaft attached to the drill chuck is at a 290 degrees to the lathe bedways. When all is set up, some marking out blue is applied to the workpiece in the lathe chuck. Then with the digital caliper, a line is scribed at the correct distance from the end of the buffer head. Then the handheld drill can be attached to the assembly and the drilling operations can commence. The lathe chuck should be locked off at the headstock such that it can't be revolved manually by accident, and the electrical supply isolated to the lathe such that the lathe cannot be turned on, as damage would occur to the lathe. A centre drill is set up in the cross drilling chuck which has been adjusted to be on the centre height of the work. Then the centre drill is used to create a centre, followed by a long drill the correct size for the tap. Cutting fluid is applied to the tap and the hole is then tapped right through into the bore of the buffer head. A redundant chuck can be attached to the end of the drilling fixture shaft, such that we can go as slowly and as steadily as we require when tapping with the attachment. When tapping with any device, it's good to be able to have feel of how well the tap is doing through the steel, such that you don't snap the tap, and such that you can reverse the tap out of the work to clear the swath, to prevent the tap getting clogged up and snapping in the workpiece. With the spring inserted in the end of the buffer shaft, and the hole drilled and tapped suitable for the desired machine screw, that concludes the work on the back of the buffers.